Okay, this is a quick video, or hopefully a quick video on simple probabilities. I think you're all fairly familiar with it. Just notice the word, we're talking theoretical at the moment. Theoretical means that you look at a problem uh, and you look at the situation and you consider all possible things that could happen and assume that each set of outcomes is equally likely to calculate the probability. So let's start with the simplest one. We've got a coin toss. Coins have two sides. You've got a head and a tail. Tails normally have the value on them, and the other side, normally the heads. Most countries at some point had the head of the um, monarch or the person who was in charge on it. So you had coins with Julius Caesar, Napoleon Bonaparte. UK still has the Queen. The American has various presidents. Uh, Kazakhstan, we've got the national emblem on one side. The tail side, which is normally the one which has the price. So there's two possibilities. Chances of landing on the edge are extremely small if you're on a hard surface. It does happen. At some point, I'll put a link into a video for Matt Parker. He did it a little search for the number of he did some experiments with some, and within a fairly large area, they're tossing a coin, and they did it some like 10,000 times and counted how many edges they got. Incredibly small. It does happen, but for all the situations we talk about, we don't deal with it. So coin toss. We say things like the probability, normally written as a capital P, and then what goes in brackets is the experiment being tested, the test. And so what we could say is the probability of a head. And I think you all probably know there is one head out of two possible sides. So we've got the occurrences of what we looked for out of the all possible chances. Okay. We talk, if you are doing the warm up I did, you should be coming across some things to do with cards and decks of cards. And what you could ask in here is things like, what's the probability of a face value card? Face value means the card actually has a number written on it. So face value card. Now, there's two ways of going about it. You could consider all cards. So all the cards in a deck of cards should be 52 cards. If you do the face values, we've got 4 rows of 1, 2, 3, 4, 5, 6, 7, 8, 9 cards. So 9 times 4, 36. The other way to deal with it is because we've got similar groups, so we could look at a suit and each suit is similar. If they're not similar, you can't make this rule. But if the suits are similar, I only have to look at one of them. So the hearts, the bottom there. Probability there of a face value is 9 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 13. And what you may notice is these two fractions are the same. If I calculated them, I can actually simplify that by 4, and that gives me 9 out of 13. Other things they may say, what's the probability of getting a royal heart? Now the royal cards are these ones. They're the Jack, Queen, King. the Jack, Queen, King, there's 3 hearts. Out of a whole deck, we get 3 out of 52. If you want to do a quick check, if it simplifies, 5 plus 2 is 7, doesn't divide by 3, so that is a simplified value. You may get asked things like the probability of a black even. So we need to look through the deck of cards. There's 52 of them. And how many even ones are there? 2, 4, 6, 8, 10. Or, because I know that there's half the deck are red, I could think about the 26 of these top 2. How many of them are black? An even 1, 2, 3, 4, 5. That will give me 5 out of 26. Another way of doing it. Quick note with probabilities, unless told to, you do not have to simplify, and sometimes it makes less sense to simplify the fraction. This, black evens, that shows better what the situation is. It shows that I have considered all 52 cards and 10 of them were what I was looking for. A couple of other ones, things you might get asked is the probability of, let's go back to my normal colour, the probability of a black square randomly chosen. So what you might do, how many blacks are there? Well, there's 32 on a chessboard. How many squares altogether? It's 64, 8 by 8. That sort of thing comes up. You could be asked how many squares have pawns on them at the start. Well, you could do it in a number of ways. Probability start square has pawn. So how many pawns are there? Well, there's 8 on the black, 8 on the white. So we've got 16 out of 64. Simplifies to 1/4. And notice we could have done how many ranks? There are 2 ranks of pawns out of 8, which simplifies to 1/4. If you can group logically, it's worth doing. Things you might get asked, other ones are a random pool table. What's the probability of the ball going down the hole? Now, these sort of questions in a hole, they're really quite dodgy. You shouldn't see them in exams anymore, but they have been online a few times. And if you watch things like Hell's Kitchen, at the end, he gets down to, oh, we've got 6 people in the left. The likelihood each of you has a 1 in 6 chance of winning this competition. It's not true. Some of those contestants have already shown they are a lot better than others. The others just haven't been knocked out. So this is probably one where I'd say this is really not true. Probability of a ball going to a random hole. In pool, what you'll find is that hole and that hole are more likely than the sides. And you probably find that this is the most likely hole just simply because most people are right-handed and they'll play into this side a lot happier. Then that hole, and in the same rule, then that one, then that one. And sides are normally considered the hard pockets to go for. So probability of a ball going in a hole theoretically is 1 in 6, but in practice, which we'll come back to later, it's wrong. That would be false. This would be false. Especially if you've got good pool players. Good pool players, they will be playing into corners on long shots. More likely ones are things to do with things like snooker table. So they'll talk about things like the probability of a random ball being red. And if you don't know a proper snooker table, you've got 6 colours. You've got yellow, green, brown, blue, pink, and black. And that's actually the order of their scoring. So you get 2, 3, 4 points, 5 for a blue, 6 for a pink, 7 for a black. And there are actually, if you look at it, it's a triangular group of 5. So there are actually 15 by 1 point reds. If the question comes up with this, you also have to think, do we include the cue ball? So if we include the with cue ball, which is 1 white, what's the probability of a random ball being red? Sorry, I missed the red off. So we've got 15 reds with another 6 colours is 21, plus the cue ball, which is 22 balls in total, of which 15 are red. Okay. Last couple of bits on dice for the moment. Here's a couple of packs of dice. You should all be familiar with the standard 6-sided dice. Probability of a number on a normal 6-sided dice. Let's choose a 5, a 6-sided dice. And Oxford English Dictionary accepts the word dice as being singular as well as being die. So die traditionally went singular, but dice is acceptable now by the OED. Okay, so people are not should not be correcting you if you use the word dice. So 5 on a standard dice, there are 6 faces, so the probability is at 6, and only one of them has 5 on it. It doesn't matter what the value of that 5 is for the probability of it occurring. When we come up to the expected score on a dice, yes, the 5's needed. Just a little side, these 2 dice are tetrahedral and they're weird. They're often referred to as D4 dice. Anybody who plays role-playing games may actually have come across these. And my question for you is, both of these dice are showing the same number. What score is it? Leave your answers in a comment or in your answer book, please, for this exercise. I'm going to finish that video there.